Okay. Torque external would be is equal to dl upon dt is already knows. dl upon dt. Torque is equal to dl upon dt. If external torque is equal to 0, if torque external will be 0, then what happening is that dl upon dt is equal to 0. dl upon dt is equal to 0 means what is the meaning that L is equal to constant. L is equal to constant means initial momentum of the system is equal to final momentum of the system will be the equal. Or initial momentum of the system, initial angular momentum minus L final angular momentum would be is equal to 0. Or simply delta L would be is equal to 0. This is called as the law of conservation of angular momentum. Law of conservation of angular momentum means if the net angular momentum on a system is 0, then this is called as a law of conservation of angular momentum. For law of conservation of angular momentum, initial momentum of the system will be equal to final momentum of the system. Both will be equal. Okay. See, based on the concept of law of conservation of angular momentum, see the some problems here. Suppose consider a rod you have and a J problem you have. This is a J problem. See, J problem. Suppose consider a rod. This is a rod. This is a rod. Okay. It has a mass 4m. It has a mass 4m and length L. Okay. This is a uniform rod. What kind of rod? This is a uniform rod. Uniform rod. Uniform rod has a mass 4m and length L. Okay. So from this, a particle from the one end of the rod, what did I do there? See here, from one end of the rod, this is one end of the rod. From one end of the rod, a particle of mass m, this is a particle of mass m, which is projected with a velocity v, like this, which is projected with a velocity v, making an angle of 45 degrees, with the y axis. Okay. And this rod would be pivoted. The center of the rod would be pivoted here like this. The center of the rod would be pivoted on a sharp edge. This is called a sharp edge. Sharp edge. Okay, on sharp edge, this rod was pivoted. When this when this mass is projected with a velocity of v meter per second, making an angle of 45 degrees, after hitting this particle at this end, then calculate what is this, the angular velocity of the rod. Okay. Let's take the total length of the rod would be equal to how much meter? It would be equal to L here. Okay. So from the hinging point, the center of mass has to be hinged at the sharp edge. So this remaining length would be equal to L by 2. This length also is L by 2. The remaining length would be also L by 2 हो जाता है, ठीक है? About this point of touching, this velocity can be resorted to rectangular components, which is coming to along this direction on this, but this velocity has in the two-dimensional plane. The two-dimensional plane velocity could not be hit. So which is must be hit along the direction only. So this velocity can be resorted to rectangular components. One in the direction of angle, what is that? V cos theta, V cos 45. Other than direction of angle, V sin 45. So V cos 45 is equal to V into 1 by root 2. That is equal to, with what velocity it could be hitting along this direction, which is hitting v by root 2 velocity with v by root 2 velocity, it would be heating like this. Okay. So after heating the rod, find the what is that angular velocity. Both are some problem. So which is the base? This question was asked based on the concept of law of conservation of angular momentum only. Therefore, initial angular momentum of the particle is equal to final angular momentum of the system. Both will be equal here. So it has a mass mvr, m into v value is with what velocity it would be heating, v by root 2 into r. R means what is the perpendicular distance about this point of contact is already known. What is the perpendicular distance from this point of contact into L by 2 is equal to I into omega is already known. This is what I am writing. See here, mvl upon 2 root 2 is equal to I means what is the total moment of inertia about this center of mass is given with respect to this point of contact is what is that I is equal to mr square. M means 4m into r square L square upon 12 about the center of mass plus the moment of inertia of this particle about this touching point, that is equal to m L square by 4 into omega. With what angular velocity it would be rotating, which is rotating with an angular velocity of omega. Is it clear? So from this it is very clear that m v L upon 2 root 2 is equal to 4 1s or 4 3s. Okay, that is equal to ml square by 3 plus ml square by 4 into omega. Now we have to calculate the value of omega. ठीक है, कैसा निकालना पड़ता है बोलो? m v l अपॉन 4 है बेटा 402 और दोनों का क्या है बेटा 4 1 4 3 12 एलसीएम है सर. The 12 LCM is a 12 LCM 4 ml square 4 ml square plus 3 ml square है बेटा 4 ml square plus 3 ml square into omega. That is equal to m v l upon 2 root 2 is equal to 7 ml square 7 ml square upon 12 into omega. On both sides our m also gets cancelled out. One L and one L also gets cancelled out. So 2 1s are 2 6 are 12 will be gets cancelled. The remaining rest terms are the what are the remaining rest terms? See here. V by root 2 V upon root 2 is equal to 7L upon 6 7L upon 6 into omega. इससे क्या निकालना पड़ता है? इसमें क्या निकालना पड़ता है? ओमेगा निकालना पड़ता है. व्हाट इज द वैल्यू ऑफ ओमेगा? हियर ओमेगा इज इक्वल टू 6v upon root 2 into 7L. This is the angular velocity of this rod after hitting this particle. I hope that you may be understood. Okay, note down. Next see. Next problem see. Next also J problem. This also J problem. Li is called LF is the angular momentum. Based on the concept of angular momentum, questions are asking in the J mains and advanced paper about important concept है. For example देखो इधर. Suppose consider a cylinder है बेटा. एक cylinder ऐसे है. This is a cylinder. This is a cylinder. Okay. Suppose consider a cylinder है बेटा. Cylinder ऐसे है. This is a cylinder. Okay. This is a cylinder है बेटा. Cylinder. This is a cylinder. Over the cylinder, what happening is a rope has to be wrapped like this. rope has to be wrapped like this. The rope has to be wrapped. From the second end of the cylinder, what did I do there? A block of mass M is hanged like this. A block of mass is hanged from the ground, which is at a height of h. Okay. At a time t is equal 0. At a time t is equal 0, the block would be at a height of h meters a beta. The block would be at a height of h meters. The block would be at a height of h meters from the ground, I saw. At a height of h meters from the ground. At t is equal 0, the block would be at a height of h meters from the ground. So after releasing, either velocity also 0, its velocity 0. After releasing, what happening is there? With what velocity? After releasing, with what velocity it could be reach the ground? With what velocity it could be reach the ground? That was the question. I showed in the figure. After releasing the block of mass m, with what velocity it could be hitting the ground. Let's take this a cylinder. The cylinder of mass capital M and length L. Right? This is a cylinder beta. This is mass M and length L. When it is releasing, what happening is that the cylinder is rotating like this. The cylinder is rotating. So before releasing that, this block of mass possesses only potential energy only. After releasing, it will be getting potential energy as well as rotational kinetic energy. Is it clear? Potential energy as well as rotational kinetic energy. Therefore, according to law of conservation of energy, initial energy of the system is equal to, what is that? EI is equal to EF, दोनों बराबर हो जाता है. According to law of conservation of energy, EI means it has, what is that, only mgh. Mgh is equal to half mv square, translation energy of this particle, this body, of mv square, plus rotational kinetic energy. It is rotating with an angular velocity omega. That is plus half I omega square. Translational kinetic energy plus rotational kinetic energy of the system would be remains constant. So we have to calculate what is this. We have to calculate the V value here beta. That is mgh is equal to half m v square plus about this axis of rotation. What is that moment of inertia? Capital of into m r square by 2. mr square by 2 into omega square. This is cylinder है ना, वो cylinder है. This is cylinder. What cylinder है? Solid cylinder है. Solid cylinder को press करो. solid cylinder को press कर क्या मिलता है बेटा? Disc मिलते हैं. solid cylinder को press करते तो क्या मिल जाता है? Disc मिल जाते हैं. You will have to get disc. The moment of inertia of the disc about this center passing through the center perpendicular to the plane is equal to m r square by 2. Which is rotating with an angular velocity omega. Okay, but v is equal to r omega is already known, which is rotating now. About this axis of rotation, the cylinder would be rotating like this with an angular velocity omega, which is rotating like this. So that's what I have written. What is that? mr square by 2 into omega square. Therefore, but v is equal to r omega is already known. V is equal to r omega. From this omega value, I am writing V upon R. This value substitute in this equation. Then what you will get, see here, mgh is equal to mgh is equal to half mv square plus what is this? Capital M half into capital M into R square by 2 into omega square means v square upon r square. V square upon r square. Okay, is it clear? We have to calculate the value of v beta. Your r square will be gets cancelled out, and the remaining term is the mgh is equal to half mv square plus of mv square of into of mv square. From this two term, you can take common of mv square common here, beta. So I'm writing like this, of mv square. This mass and this mass are different, no? That is equal to of mv square plus of into 1/4 of into 1/2 m into v square. This mass and this mass are different as well. So from this you can take out the common v square beta. We need find out the v square or v square by 2 common karo. What is the remaining term? Small m plus v square by 2 common हो गया m by 2 आ गया. So from this what I am writing, see, v square by 2 into 2 into m plus capital M upon 2. This is equal to m g h. From this we have to calculate the value of v square. That is mgh is equal to what I am writing, see, mgh is equal to v square by 4 into 2 small m plus capital M here beta. So from this v square is equal to क्या मिल गया था बोलो, v square is equal to 4m gh upon 2m plus capital M. So from this the value of v is equal to root over 4m gh upon क्या हो जाता बोलो 2m plus capital M. This is the final answer about this question. ठीक है. A cylinder of mass m which is placed on the axis of rotation. About this axis of rotation, about this axis of rotation, and over it, what is that? A string of massless string has wrapped like this. Okay, one end is connected at this point, and another end is connected to a block of mass m. Okay, when the block of at a time t is equal 0, the block of mass m is released. Then with what velocity the block of mass m is hits this ground? That was the question. With what velocity it could be reached the ground? V is equal to square root of 4m gh upon 2m plus t. Problem, right? Find with what velocity small m it's the ground is shown in field, is shown in field. Okay, with what velocity it could be hits the ground? V is equal to square root of 4m gh upon 2m plus capital M. With this velocity, this block will be hits the ground. Is it clear? Okay. Note. See, next problem, see. Next is also this also J problem only. J problem है बेटा. Suppose consider three particles having the same mass. These three particles are placed at the vertices of an equilateral triangle like this. Suppose consider three particles. Are placed at the vertices of an equilateral triangle like this. The particles each having the mass m. Okay, so having the mass m है. हर एक particle has the same amount of mass ऐसा है. Okay, which are placed at the vertices of an equilateral triangle A, comma B and C. For the all particles I have given same amount of velocity बेटा. इसका velocity v दिए, इसका velocity v दिए, इसका velocity v दिए. हर एक particles को same amount of velocity दिए. I have given same amount of velocity. Okay. I have given some same amount of velocity. Find the angular momentum at the point of collision at the center of the equilateral triangle. Find the angular momentum. Find the angular momentum. Angular momentum. Find the angular momentum of the system at the point of collision. At the point of collision. Point of collision. At the point of collision of center of the triangle. Point of collision of center of triangle. Center of triangle. Center of the triangle. I shown in film. I shown it. I said better. This point, center means at this point, we have to calculate the angular momentum. Okay. कैसा निकाला पड़ता है बोलो? हर एक पार्टिकल का सेम वेलोसिटी दिए. When I have given same amount of velocity, all the particles, this particle also approaching like this direction. This particle also moving like this direction. This particle also moving like this direction. These three particles will be collide at the center. When they are when they are taking interaction at the center at this point, when the three particles are taking interaction, physical interaction at the center, at this point, angular momentum का system क्या हो जाता है? What would be the angular momentum when these three particles are taking physical interaction at the center? That is we have to calculate. Okay. So what is the side of the triangle? Side of the triangle was not given. Let's take it is an equilateral triangle. So each side of length A level. Each side of length would be is equal to A. Each side of a length would be equal to A level. Okay. Now I have to calculate the perpendicular distance beta. One perpendicular to draw on what I have taken is the AB line on AB, which is intercept at a point of D, and which is makes intercept at a point of D. So whatever this total angle would be is equal to 60 degrees. So whatever this angle? This angle is 30 degrees. Whatever this distance we don't know. The perpendicular distance we don't know. We have to calculate the perpendicular distance about this point of interaction. Let's take the perpendicular distance would be is x. Okay. This total distance I have taken here, which is perpendicular put bisecting on AB. So this length would be A by 2. This half of the length, this length would be A by 2. The remaining length also is A by. So from this triangle, what I'm taking, see, here ADO is one triangle is there. So from this triangle, this angle is 90 degrees से बेटा वो भी hypotenuse हो जाता है. ठीक है. From this triangle, what I am taking tan theta लो, tan 30. Tan 30 is equal to opposite side by adjacent side, that is x upon A by 2. X upon क्या हो जाता है बेटा? A by 2 हो जाता है. X upon A by. So from this, what I am writing, the value of x is equal to A by 2 into tan 30. This is the tan 30. So tan 30 value also already 1 by root 3 है. That is x is equal to A by 2 into 1 by root 3. Therefore, x value is A upon 2 root 3 आ गया है. Okay. The perpendicular distance we have calculated. All of them are moving with the same amount of velocity. V0 here. This is also V0. This is also V0. And it is also has a V0. The angular momentum at this point of contact is given by L is equal to M into V0 into R perpendicular is already known. This is only for one particles. So how many particles are there? Total 3 particles are there. Into 3 से multiply करो. Then the angular momentum is given by M into V naught into R perpendicular in the thematic the x है तो भी x that is A upon 2 root 3 into T से multiply करो. Okay, this is what I am writing. See here, this is what I am writing. This is what I am writing. See here. So L is equal to mv naught into A upon 2 root 3. This is in the root 3 value I am writing. 3 value root 3 into 3 I am writing. This 3 value I am writing in the form of root 3 into root 3. One root 3 gets cancelled out. Therefore, the value of L is what is the value of L? The angular momentum is given by mv naught. Sir, class lo unna. Sir, class lo unna. Okay. That is what I am writing. See here. mv naught to root 3 into m v naught a upon 2. So this is a net angular momentum of these three particles at the point of interaction of their masses. Is it clear? Is it clear or not? Okay. Note down. Next problem, see, based on the concept of angular momentum only. This is also J problem hai beta. J problem देखो. Suppose consider a disk. Do you know disk? This is a disk. This is a disk. It has a mass m and radius r, which is rotating with an angular velocity of omega about this axis of rotation. This is an axis of rotation, which is rotating with an angular velocity omega. Okay, is it clear? Okay, with an angular velocity omega. Now, when two particles each having the same amount of mass, small m beta, so small m, it is also small m. Two identical particles having the same amount of the mass m are suddenly or gently placed on the on the edges like this. Then what will be its angular velocity changes? Okay. What will be the changing angular velocity of the disk? That is we have to calculate now. Okay. What will be the change in angular velocity in this case? That is we have to calculate now. Okay. How can we have to calculate change in angular velocity? Find the change in the angular velocity of the system as shown in the figure. Find the change or find the angular velocity of the system as shown in the figure. Find the final angular velocity. Find the final angular velocity of the system. As shown in figure. Okay. When the disk is rotating like this, it has some angular velocity initially. Okay. When two particles are gently placed over it, what happening is that automatically its angular velocity changes. Okay. So what is the disk? This is a disk which is rotated. Let's take the radius of the disk is r already we have taken. Therefore, L is equal to constant beta, angular momentum L is equal to constant. That is equal to initial angular momentum is equal to final angular momentum को बराबर हो जाता है. Initial angular momentum क्या है बेटा? I1 omega 1 is equal to final angular momentum I2 omega 2 को बराबर है. So both will be equal. I1 means what is the moment of inertia about this axis of rotation of the disk, initial angular momentum. The initial angular momentum of the disk about the axis of rotation is what is that? mr square by 2 into omega 1 was given omega left. That is I2. I2 means ICM plus mx square or md square is already into what is that omega 2 here? That is mr square by 2. mr square by 2 into omega is equal to ICM means mr square by 2 plus this is 2 particles, sir. 2m into r square. This is 2m into r square here into omega 2. We have to calculate the value of omega 2 here. These particles having a small amount of the mass. The disk has a big amount of mass. That is, I am represented by capital F. Therefore, mr square by 2 into omega is equal to mr square by 2 plus 2m into r square. This is what I am writing. See here. This is what I am writing. See here. mr square, capital mr square plus 4m into r square by 2 into omega 2 I am writing. Now I have to calculate the value of omega 2. What is the value of omega 2? See here. The value of omega 2 is on both sides 2 will get cancelled out. Omega 2 is equal to capital M r square upon capital M r square upon mr square plus 4m r square into omega. This is a final angular momentum of the system. Is it clear? The final angular momentum of the system is given by what is that? Omega 2 is equal to mr square upon mr square plus 4m into r square into omega. Is it clear or not? Okay. Note down. Next, see equilibrium of a particles. Equilibrium of a particles. First one is the translational equilibrium. Translational equilibrium. Translational equilibrium. In translational equilibrium, in translational equilibrium, so what are the components are zero and which components are not zero? See here. Suppose consider a rod here, beta. This is a rod. Okay. It has a length r here from one end to it has a length r like this, and other end to it has a length r here, beta. Same amount of the length here. Neither yellow कोई problem r length here. कोई भी problem नहीं. The rod has a length L like this. Okay. It has a length L. Okay. It has a length L. So from the center of mass to one end of the rod length would be L by 2. The remaining length of the rod would be is also L by 2. Okay. For translation equilibrium, what is the translation equilibrium? In the translation equilibrium, the net force acting on the system would be is equal to 0. F1 OBFA OB. Translation नहीं हो जाता है. Translation नहीं हो जाता इधर. Translation में net force acting on the system is equal to 0. If the net force acting on the system is equal to 0, then the system is said to be in translation equilibrium. That is, F net must be 0. F net must be 0. In translation equilibrium, the net force must be 0. F net must be 0. F net is equal to 0. Torque may or may not be 0. Torque tau net torque may or may not be zero. May not be zero. May or may not be zero. Net torque may or may not be zero. So in this case, about this point, the force would be acting along the direction. This also acting along the direction. What happening is the net torque is equal to tau net is equal to F cross L by 2 about the point O plus F cross L by 2. So this is a net torque ho jata. About point O, about this point O, the net torque would be is equal to F cross L by 2 plus F cross L by 2 ho jata. F net must be 0. Tau net may or may not be 0. Then the particle is said to be in translational equilibrium. Next, second one is this is the first one. This is the first one. Second one is the rotational equilibrium. Rotational equilibrium. Rotational equilibrium. In rotational equilibrium, what happening is there? See, in the rotational equilibrium, suppose consider a rod of length L which is fixed like this. Okay. In rotational equilibrium, what happening is that the force which is acting along the direction one force, other force also acting along the direction like this. Okay. In rotational equilibrium, what happening is that in rotational equilibrium, tau net must be 0. Tau net is equal to 0. F net net force may or may not be 0. May not be 0. May not be 0. May or may not be 0. Net force may or may not be 0. Okay. ये नेट फोर्स क्या हो जाता है बेटा 2F है. F net is equal to क्या हो जाता है बोलो इसमें F net is equal to 2F हो जाते हैं. ठीक है. So F net may not be 0. May or may not be 0 in F net. Next, third one is the static equilibrium. What is a static equilibrium? Static equilibrium. In static equilibrium, what is the static? Static means it could not be moved, it could not be rotated. That is called as a static. In static equilibrium, tau net must be 0. Tau net must be 0 and F net must be 0. The tau plus F net also is equal to 0. Tau net plus F net, both must be is equal to 0. Then the system is said to be in static equilibrium. Okay, these are the different types of the equilibriums. So first one is the translational equilibrium. In translational equilibrium, F net must be 0. Tau net may or may not be 0. यह net tau ऐसा हो जाता है. Next, rotational equilibrium. What happening is that tau net must be is equal to 0. Rotational equilibrium tau compulsory 0 होना पड़ता है equilibrium पे. F net may or may not be 0. Where F net is equal to 2F. Next, static equilibrium में tau net 0 है, F net 0 है. Both of them, tau net plus F net would be is equal to 0. Is it clear? These are the different types of the equilibriums of a body. Okay. Next, move the next concept is the rotation, rolling of a body. This is a very, very important rolling motion. Rolling motion. Rolling motion. Rolling motion. What is the rolling motion of a body? Rolling motion means, suppose consider a disc, it has a mass m. Suppose consider a disc. This is a disc, beta, this is a disc. Okay. This disc has a mass m and radius r, which is contact with the surface, And about the center, it is rotating like this. It is rotating with an angular velocity omega about this center. Okay. And with an angular acceleration alpha also. So what happening is that at the point of contact, there is no relative motion. There is no relative motion between the surface and that point of contact. Okay, that means the center of mass is moving like this with a velocity of VCM. That means it has a translation. Along with the translation, it is rotating like this. It is rotating like this, rolling. It is rolling like this. Okay, the center of mass is displaced from one point to other point like this. Center of mass is displaced from one point to other point. Center of mass has to be displaced from point 1 to point 2, P1 to P2. That means the center of mass has in the translation motion, and this disk is a rolling. It has a rolling motion. That means translational plus rotation. Translation plus rotation. The system has the two types of the motions. First one, translation. Center of mass is moving linearly, and the disk is rotating. That means the disk is rolling. That means translation plus rotation. The combination of these two motions is called as a rolling. The combination of two motions is called a rolling motion. What is that called? Rolling. Is called as a rolling motion. Rolling motion means what is the what motion? Translation plus rotation. Translation plus rotation is called as a rolling. Other motion is called as the rolling motion. Okay, is called as a rolling motion. Here see this it is has the two types of the rolling separator. One is a uniform pure rolling, and second one is a non-uniform pure rolling. For uniform pure rolling, it is also two types. First one is a this rolling also has the two types. First one is uniform pure rolling. Uniform pure rolling. Uniform pure rolling. The first one is uniform pure rolling. In uniform pure rolling, what happening is there? In uniform pure rolling, at this point of contact, there is no relative motion. At the point of contact, 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 there is no relative motion. There is no relative motion. Relative motion. The point of contact, there is no relative motion. Relative motion. And in this, all the particles on the disk are rotating with the constant angular velocity. Omega is equal to constant. It is also rotating constant angular velocity. It is also rotating constant velocity. All the particles are rotating with a constant angular velocity. Okay. All the particles are rotating. All the particles on the disk are rotating with a constant angular velocity. Okay. Angular constant velocity, but in different linear velocities. This is a V1, which is a rolling V1. This is a V2, and this is a V3, and this is a V4, and this is a V5, and so on. So angular velocity, all the particles of the angular velocity remains constant. Relative motion. relative motion में क्या हो जाता है बोलो? All the particles on the disk, all the particles on the disk are all the particles on the disk are moving with same angular velocities same angular velocities, but different linear velocities. Different linear velocities. Linear velocities. Different linear velocities. Linear velocities. Different linear velocities. Okay. So this is called as a pure rolling. For pure rolling, you have seen what happening is that the center of mass is moving like this, VCM. At the point of contact R omega, which is acting like this, R omega will acting backward direction like this. Okay. So here see, this is I'm explaining. Suppose consider a disk beta. It's a horizontal surface. The disk has to be displaced from one place to another place. Okay. The disk has to be displaced from one place to another place, which has displaced through a small amount of the displacement delta S, the time interval of delta T. The center of mass has to be displaced this point to this point. This is also center of mass. The center of mass has to be displaced from one point to another point like this. Okay. This is I'm showing like this here. See, the center of mass here is there. The center of mass has to be displaced from C1 to C2 here. This is C1. You take C1 and this is C2, making some angle theta. A small displacement ds. A small displacement ds. They have displaced a small displacement delta s or ds delta s in the time interval of delta t. Theta is called arc radius. Theta is called what is the theta? Theta is called arc length upon radius is already known. What is the theta? Theta is equal to delta s upon what is that? R. Delta s is equal क्या हो जाता है बोलो? R into theta. Again derivative करो. Delta s upon delta t is equal to R is a constant. Delta theta upon delta t. That is delta s means delta theta. What is the value? What is this value? ds by dt. V. This is a V. V is equal to what is the V? V is equal to R omega. This is a linear velocity. This is a relation between linear velocity and angular velocity. Next, again derivative. This is dV upon dt is equal to what is that? R into d omega upon dt is already This is the what is that? A is equal to R alpha. From this alpha is equal to A upon R. This is called as an angular acceleration. Is already knows. Okay. Here see, in case of a pure rolling, a disk is in the form of a pure rolling. Okay, its center of mass is moving like this with velocity of VCM, right? In the point of contact, what happening is that its velocity V is equal to R omega will act the downward direction, backward direction, that is equal to R omega. In case of pure rolling, that net velocity of the disk could be equal to 0. That is VCM minus R omega is equal to 0. In case of pure rolling, what happening is that in case of pure rolling, what happening is that VCM minus R omega is equal to 0. So from this VCM minus RMI is equal to 0 means VCM is equal to what is the value? R into omega. R into omega. VCM is equal to R omega. So this is a condition for the pure rolling. The condition for pure rolling. The disk is rolling with an angular velocity omega, and it has a radius r. Okay. If VCM is greater than to r omega, then what happening is that the disk would be slips forward. The disk slip in forward direction. Forward direction. The disk could be slip in forward direction. Next, if VCM is greater than to r omega, then the disk will, here you should write will, the disk will, what happening is that, then the disk will, then the disk will slip in backward direction. The disk will slip in backward direction. Backward direction. Backward direction. So these are the conditions for the pure rollings. Okay, it is very, very important for the mains and advanced level. See here, what is the condition for the pure rolling? VCM is equal to r omega. Is it clear? If VCM is greater than to r omega, the disk will slip. What is that in the forward direction? Forward direction में slip हो जाता है. If VCM is greater than to r omega, sorry, this is a less than. It's a less than, because they have written greater than only. It's a less than. It's a less than r omega. Then the disk will slip in backward direction. These are the conditions for a pure rolling. Is it clear? Is it clear or not? Below, respond. Okay. Next concept is that. Next, non-uniform pure rolling. Non-uniform. In the previous case, we are not considered the friction force. But here, see, in case of non-uniform pure rolling. Non-uniform pure rolling. So what is the non-uniform pure rolling? See, suppose consider a disk is rolling like this non-uniformly. That means its acceleration, center of mass of acceleration is ACM. It is rolling with an angular velocity omega, with an angular acceleration alpha, and it has a radius r. Okay, if ACM is equal to r alpha, which is contact with the ground only like this. Okay, if ACM is equal to r alpha, is called non-uniform pure rolling. If ACM is equal to r alpha, is called non-uniform pure rolling. In this case, there is no friction between the contact surfaces. If ACM is equal to r alpha, then there is no frictional force. No frictional force between the contact surfaces. There is no friction force between the contact surfaces. Here there is no have any friction. There is no any amount of friction here. Here friction is equal to 0. This is the first one condition. In the second one condition, if ACM is greater than to r alpha, if ACM is greater than to R alpha, then between the contact surfaces, some static frictional force will be arises. Then between the contact surfaces, static frictional force, static frictional force, frictional force will be arises. Static friction force will be arises. So in this case, what happening is that it is in the form of, in this case, the center of mass is moving with PCM is equal to R alpha. These are the conditions for non-uniform pure rolling. Is it clear? What are the conditions are there in pure rolling? For pure rolling, conditions are VCM is equal to R alpha. Okay. There is no frictional force between the contact surfaces because of there is no have any relative contact between the yes. In case of pure rolling, VCM is equal to R omega. Okay, there is no any relative motion between the contact surfaces and the disk. If VCM is equal to VCM is greater than R omega, what happening is that then the disk will be slip in the forward direction. If VCM is less than to R omega, then the disk will be slip in backward direction. Okay. Next, in this case, in case of non-uniform pure rolling, ACM is equal to R alpha. Okay. Then there is no frictional force between the contact surfaces. Second one, if ACM is greater than R alpha, then between the contact surfaces, the static friction force will be arises. So in this case, VCM is equal to R alpha. So these are the conditions for a rolling motion. Okay. Is it clear? Understood or not? Below. Next, see, suppose consider a disk has a mass M and a radius R, which is rolling on this. Suppose consider a disk, it has a mass M and radius R, which is rolling on the horizontal surface like this, which is rolling like this, which is rolling on the horizontal surface, which is rolling on the horizontal surface like this, with an angular velocity omega, angular acceleration alpha. The center of mass is moving with velocity of VCM on the horizontal surface. Okay, is it clear? The center of mass has to be shifted from C1 to C2 like this. Okay, on this, how many energies are acting on the disk? How many energies are acting on the disk? Two types of energies are acting on the disk. First one, translational kinetic energy. It's a translational kinetic energy, KET. And second one is a rotational kinetic energy. What is rotational kinetic energy? Rotational kinetic energy is a KER. Two types of the energies will acting on the disk. Okay. How many energies? First one, translational energy, kinetic energy. KET is equal to half mv square, mvcm square, mvcm square. And second one is rotational kinetic energy, KER. KER is equal to half I omega square. So these two types of energies will acting on the disk while it is what is that, rolling on a horizontal surface. Okay. Therefore, the total energy of the disk can be written as, what is the total energy? What is the total energy? The total energy of the disk can be written as, what is the total energy of the disk? The total energy of the disk can be written as, what is the total energy of the disk? What is the total energy of the disk? Total energy is what is the total energy? The total energy of the disk is equal to TE is equal to KE translational plus KE rotational. This is the net energy or total energy acting on the disk. Okay. KE translation means what is that? Half M VCM square plus half I omega square. Half I omega square. So what is the I? I nothing but a moment of inertia. This is not a disk, any object. It may be any object. This is any object, not a disk. Particularly, you don't maintain like a disk. Suppose wheel maintain, this is a wheel. Wheel. Let's say it's a wheel. So wheel. Okay. What is the I means moment of inertia of the wheel about this axis of rotation. That is equal to half m ECM square plus half mk square into omega. Omega means VCM by R of 4 square. Because of omega is what's omega? Its omega value is omega. What's the value of omega? See? What's the value of omega? V is equal to R omega, no? VCM is equal to R into omega. From this omega is equal to what's the value of omega? Omega is equal to VCM upon R. This is the angular velocity of the wheel. So from this, what was the common? From this, what I'm taking common, see here, of m into VCM square common karo is by 1 plus k square upon r square. This is the total kinetic energy of the wheel or body. The total kinetic energy of the body is given by K is equal to 1 plus k square upon r square. Where k square plus k square upon r square is what is 1 plus k square, where 1 plus k square upon r square is called, what is this called? Rotational constant. Rotational constant. It is generally denoted by beta. That is, total energy is equal to half m VCM square into 1 plus beta. So not a k square by r square, just this is a k square by r square. That is 1 plus beta. This is called as a total energy of the body. Is it clear? So the total energy of the body changes with respect to shape of the body. The total energy of the system can be changes with respect to shape of the body. Suppose consider what is that solid cylinder. For solid cylinder, or for solid cylinder को क्या हो जाता है बेटा? Solid cylinder को क्या हो जाता है बोलो इधर? Suppose consider a solid cylinder है बेटा. SS means solid cylinder. About this axis of rotation, what is the moment of inertia about this? I is equal to 2 by 5 mr square. No? These are axis of rotation. Axis of rotation. About this axis of rotation, I is equal to 2 by 5 mr square. This is not a solid cylinder. Therefore, the total energy of the solid cylinder is given by TE is equal to is already known. What is that? Of m into VCM square into 1 plus k square upon r square का बराबर है, ठीक है? But I is equal to what is the moment of inertia of the solid cylinder? I is equal to 2 by 5 mr square is which is equal to mk square. On both sides, gets cancelled out. K square upon r square is equal to 2 by 5. K square upon r square is equal to what's the value of k square upon r square is equal to 2 by k square upon r square is equal to 2 by y. So this value substitute here. This way substitute करो. Therefore total energy is given by P is equal to what is that? Of m VCM square into 1 plus 2 by 5 है बेटा. So 2 by 5 हो जाता है. That is T is equal to क्या हो जाता है बोलो? Of m into VCM square 7 by 5. 7 by 5, that is equal to TE of the solid cylinder is 7 by 10 into M VCM square. This is the total energy of the solid cylinder. Okay. Okay, understood or not? Okay, today class, do you have any doubt? Please.